Welcome back. Eitan Suez here, Technical Marketing Manager at Solo.io. In this lesson, we cover the subject of Canary releases and how they pertain to the Kubernetes Gateway API. In the previous lesson, we covered a concept called policy attachment, which is a pattern for extension of the Gateway API model. In this lesson, we look at Canary releases with the Gateway API. Let's begin with just a simple overview of Canary releases so we understand what it is, and then we'll overlay on top of it some specifics that we'll use in the demonstration that's coming up. So a Canary release is essentially a process or an algorithm for doing an upgrade from one version of an application or service to another. Some things we could say about it is it offers the notion of a zero downtime upgrade. Some have called it a refinement on the blue-green deployment strategy that just switches from one version to another. The primary or distinguishing characteristic of the Canary release is that it does this in a sort of progressive fashion. Now, the concept, or part of the objective, I should say, of Canary releases is minimizing the impact of a failure in the new version that we're introducing through an early detection mechanism, right? Hence the name Canary, as in, of course, canary in a coal mine, an early detection mechanism. And it involves sending only a small fraction of traffic to the new version to minimize the impact of a possible failure while monitoring the application for failures and maybe different kinds of regressions. And then the procedure is to progressively increase or to shift traffic from the old version to the new version until the rollout is complete, and that sort of summarizes the description of a Canary release, and it's become commonplace these days. There is, of course, the idea that if something along the way doesn't go as planned, we can roll back or revert to the old version of the application. Now, when we do this manually, of course, there's different ways to go about it. In Kubernetes, we typically configure two distinct services backed by two distinct deployments. Many sample applications you look at have this model. For example, in Istio, we look at the book info application. It has multiple versions of the review service, and each has its own service and deployment. And we typically see a version label sort of attached to the pod template on the deployment, which allows the service to use a selector to essentially select the right version of pods that match the particular version. Then there's the notion of using weights in a route to essentially shift traffic. So we start out with 100% of the weight to the so-called stable or current version of the application, and then the idea is that we manually can edit our routes and alter those weights to shift the traffic as we sort of monitor the system's health in the process. So let's talk about Argo rollouts, which is a cloud-native project, a CNCF project that we're going to be using in the demo that's coming up. We can go and visit its webpage. It's a very popular option for doing or in automating Canary releases, which is the point. We don't want to do this manually. We want to do this in an automated fashion. Flagger is another well-known project for what we call progressive delivery. So this is a progressive delivery controller. So it's designed to automate the process. And the way that it models this sort of Canary release, or it actually offers different strategies, but Canary is the predominant one. It uses this concept of a rollout resource and defines a rollout strategy using a series of steps. So that's an important sort of mental model to keep in mind. And then you have the option, some of your steps can actually be what we call a pause step that allow you to sort of pause the rollout so that you can inspect the state of a system. And even that part of a Canary can be automated through integration with metric systems, which give you the feedback necessary to determine if the system is healthy at any particular point in time. We can unpause a rollout and allow it to continue. That's usually known as a promotion action or promote. And we can roll back the rollout to an older version. So those are typically some of the capabilities that we can perform. Now, what's interesting is that historically, of course, we didn't have a standard for how you do this shifting of traffic. Every different solution had a different API, and so when you look at Argo rollouts, the predominant thing you'll see is instructions that show you how to do something using different solutions, different traffic management solutions, whether it's Istio or Ambassador or something else. With the Gateway API, we have an opportunity to maybe clean that up. But let's see, where was I? Yeah, okay, I think I was on this slide. So the support for the Gateway API is now available in the form of a plugin. We can go and visit the documentation for that plugin. It's essentially a plugin for Argo rollouts that allows the implementation of Argo rollouts progressive delivery in terms of the capabilities, the underlying capabilities that the Gateway API provides. And those namely are the ability to conditionally send traffic to a Canary through the header-based matching capability. So oftentimes what we want to do is stand up a Canary and before we even start shifting traffic to it, maybe allow requests with specific headers, for example, to target the Canary for testing purposes. And then the progressive traffic shifting is performed by editing an HTTP route and updating the weight fields on those backend refs that we've seen in previous examples. So the main one of the takeaways is the fact that Argo rollout is automatically editing those HTTP routes and must be given permission to edit those routes. Now, some conventions that Argo follows, which sort of help us understand how it functions, is as follows. Instead of a Kubernetes deployment, we're sort of substituting a deployment resource with a rollout resource, which Argo provides. It's one of its central custom resource definitions. And you can think of it as a deployment. It has replica sets and it has pods, and the replica sets beget pods. But it also, in addition, allows as a section for specifying a rollout strategy, which we'll look at an example as we go through our lab in just a minute. So instead of utilizing multiple distinct deployments, really what Argo does is use multiple distinct replica sets, which are all members of the same rollout resource. The routes backend refs are usually two distinct services. One is usually called the stable, and the other one is called the Canary service. And then instead of using sort of a manually applied version label, since each set of pods for a different version is associated with the replica set, it's the template pod hash that's used as a selector on those services to actually select the right version of the application, so to speak. So we're going to do an example, and since we've been working with the Bookinfo application and HTTP bin predominantly as our sample applications, we'll stick with that theme and look at the reviews service, principally because it has 3 versions, and we're going to begin with a deployment of the reviews. We're going to create a route for it that will point to version 1, and then we'll do a Canary release to version 2. And the main sort of distinguishing characteristic of version 2 is that it actually calls an upstream service called the rating service, whereas version 1 does not. So we'll be able to tell them apart. All right, so we're about to start a lab. In the lab, we'll deploy Argo rollouts, and then we'll deploy and provision a gateway and configure the gateway and the route for it for the reviews service. And then we'll define a rollout. We'll look at what those rollout resources look like, and then we'll actually go ahead and do a Canary release by updating the version of the image of the review service from v1 to v2, and we'll sort of observe that as the Canary release sort of takes place. All right, so let's shift gears and come over here to our sandbox environment. And I'm going to forego the introduction, which we just already made. Our initial state is a Kubernetes cluster that's running. There's not much here other than kgateway being installed and the Gateway API CRDs were applied. And the first thing we'll do is more of an operator pattern. We'll need to install Argo rollout. So we begin there. And what's interesting about the installation process is here we just, we could have used a Helm chart. Here I'm just using a kubectl apply. The controller resides in a namespace called Argo rollouts. That's the convention. And we can wait for that deployment to be ready. So once it's ready, what's interesting is we have to install the Gateway API plugin for Argo rollouts that supports doing Argo rollouts in terms of the Gateway API. And so what we actually do is replace the configuration, the config map that's associated with the controller with one that specifies the plugin. We also have to apply some RBAC to predominantly give Argo permission to edit HTTP routes, as we've said before. And then we have to restart that Argo rollout deployment, or that controller needs to be restarted. And as the new pod sort of replaces the old pod, what usually happens is as it comes up, one of its sort of chores is to go and fetch the plugin and to install the plugin. And one way that we can verify that the plugin was installed is to tail the logs, or to grep the logs of the Argo rollouts controller, and to just notice that there's a line in there, an info log line that says download complete. All right, so we've installed Argo rollouts. Now let's go ahead and set up our example. What we're going to do here is look at a simple gateway resource. So we go back to just a simple gateway run with HTTP traffic. That's not really the focus of this exercise, so I decided to keep this simple. And we'll apply that, and that'll provision us a gateway in the default namespace called my gateway. And that's in the process of becoming ready. And we'll go ahead and deploy the rating service from the Bookinfo sample application because the certain versions of the review service depend on it. And then let's look at the two services that we must define, the reviews stable and reviews canary. Currently the selector is just uses the application label, but Argo will actually play with those selectors to make the stable and canary match the version that we're deploying and the version that's already running, respectively, inverted actually. Okay, so let's apply these services, and that's part of our sort of construction of the setup. The next thing to look at is the route. So here's a route. The /reviews path prefix will route request to the reviews service. Notice that we put both backends there, reviews canary and reviews stable. Now they both point to the same thing right now, but Argo will take care to modify the selectors on those services to match the right revision. So we go ahead and apply the route. All right, and finally we get to inspect sort of the centerpiece of all of this, which is the rollout. So here we see a service account, and following the service account is the rollout resource. So here we see it's called a reviews rollout. Think of it as a deployment. It has a spec with replicas, and but the thing that stands out is line 17 and below are the actual rollout strategy. So notice the strategy is a canary release. And we define the name, or specify the name of the stable and canary services, so it knows which one is which, and then we tell it that we are going to use the Argo Gateway API plugin, and specifically the route that we want it to manipulate, the Bookinfo reviews route that we deployed a moment ago. Now the steps of the canary is where it gets interesting. When we start a canary release, the first thing we'll do in the first step is provision the canary with one replica and use a header-based matching. Notice I'm specifying the header name and value to be role QA. So presumably a QA could then, who's logging into the system, and maybe that generates a header with the matching values, will be able to access the canary while the entire population, the remaining population of users, are still using the stable version of the application. Then there's a pause step that allows us to sort of do our testing, presumably, and then finally, once we promote our canary release, the remaining steps will play, which will progressively shift the weights from 10% to 20% all the way up to 100% of traffic to the canary, which then becomes the new stable version of the application. So this is how this is going to work. The rest are standard deployment type specification, the pod template, presumably, not presumably, which actually specifies how the pods should be constructed, the specification for the pods. Notice that what we're deploying is reviews v1. So we've got our rollout. We'll go ahead and apply the rollout, and let's play with this. So Okay, so here we go. So we've got two panels, and in the top panel, what I'm going to do is I'm going to use a command, kubectl argo rollouts get rollout. This is something provided by a kubectl plugin from the Argo project, which allows us to sort of get a visual on what's going on. So the way we interpret what we're seeing here is that we have a stable version that's deployed. Right, we should be able to see this. If we do a kget pod, we should see the reviews service is running. Actually, it's the reviews rollout there. That's the pod, and it's the stable versions, version 1. There is no Canary in sight because we haven't yet done a Canary release, and everything is healthy. It knows the strategy is Canary and that there are 12 steps in all. And currently, the stable version has 100% of the traffic. So what we can do is maybe begin by making a request to the review service to make sure that this works, that we get a response. And indeed we do. It's a little cramped for space here, but here we see the response from the review service. A couple of reviewers are reviewing an article or a book. And then we could trigger a rollout to version 2. So the command is kubectl argo rollout set image. We're updating the image in the rollout to book info reviews v2. You see that there. And the moment we do this, we should see something happen at the top. We see that Canary should be deployed. And maybe I'll make the font size a little bit smaller. There we go. I'm still a little bit pressed for space. Here we go. All right, so we see the stable and Canary versions are both in play. Step is 2 out of 12, which means we have deployed the Canary and we've set up the header-based matching we were talking about, and we've paused. And so at this point in time, we should be able to verify, maybe with a header like role QA, that a request to the reviews service with that header will actually direct me to a new version of the review service. And I could tell it's a new version because in the JSON response is a reference to the rating service, which I know is called only by reviews v2. If, on the other hand, I make the same request without that header, notice that there is no reference to the rating service, and that's because we're calling reviews v1. So here we have a mechanism for being able to call the Canary before we sort of promote and continue with the rollout. And the way we continue with the rollout is by running the command kubectl argo rollouts promote. And the minute we do that, you'll see that the rollout will be unpaused. The step will switch to another step. Notice the weight is now changed to 10% and then 20% and progressively increases until all the traffic is shifted over to the new replica set. Also, if we look at the services if I do an O wide, I'll see the selector. You could actually see that one of the selectors is the rollout pod template hash, which matches the hashes of each of the replica sets mentioned here. So we see our Canary is finished, the weight is now 100%, and then the stable version has been decommissioned. All right, well that I think covers everything that I wanted to cover. Let's go back to our sort of main lessons and wrap up the lesson. And so the thing to know is that the Gateway API in this sort of scenario provides the building blocks for the Canary releases, but we don't want to perform the Canary releases manually. We want to use some kind of automation by using Argo rollouts or Flagger or maybe something else. And specifically with Argo rollouts, we learned that the rollout resource sort of takes the place of the deployment resource, which allows us to specify the rollout strategy as a series of steps, and that each revision is modeled or maps to a replica set in the rollout. Okay, so that concludes our lesson. In the next lessons from here on, we will probably sort of segue over to exploring features of the kgateway project that are unique to kgateway. I think we've covered almost everything that there is to cover in the Gateway API. Thank you again, and we'll see you in the next lesson.